The next section that we're going to do is looking at some more algebraic equations. Now I want you to refer back to the section on simple algebra that we did earlier if you are having trouble still with one-step equations. We're going to move now to two-step equations. So if you're not confident or real comfortable with the one-step, make sure you refer back to that before you continue on with this section. The key with solving one-step or two-step equations is this. Make sure you always do opposite operations so that you can isolate x. Get x by itself. Always tell yourself that in your mind. What do I need to do in order to get x by itself? That is the key. That's how you find the solution. So here's that's what I mean. If we were to have 2x plus 5 equals 10. We want to isolate x to get by itself. Always be thinking opposite operations. Before we do anything, we have to get this 5. We have add 5, so we have to subtract 5 from both sides. The opposite operation of addition is subtraction. To keep our teeter-totter balanced, whatever I do to one side, I have to do to the other. These zero out, this 2x comes down, and 10 minus 5 is 5. The next step is it's 2 times x. So in order to isolate x, I have to divide both sides by x because the opposite operation is division. These will cancel out, and I end up with 5 over 2, that's okay. We've already learned how to change improper fractions to proper fractions. I divide 2 into 5, and I get 2 1/2. Mixed number, no problem. Next one, I'm going to have 3x minus 6 equals 12. Opposite operations again. Here I have 6 is subtracted. So I'm going to add 6 to both sides to stay balanced. Those cancel out. 12 plus 6 equals 18. It's 3 times x. So the opposite operation of multiplication is division. Those cancel. X equals 18 divided by 3 equals 6. Now notice that I have not once in either of these two questions ever really mentioned what is on the other side. I'm always talking about what do I need to do to isolate x. The numbers on the other side are just along for the ride. Whatever I do to this side just happens to get done to the other side. I'm not concerned what happens with that until the very end. Keep that in mind. That'll help you. If I have a question with a fraction in it, x over 2 is the same thing as 1/2 of x. There is an understood 1 right here as a coefficient. So you may sometimes see it as 1/2 x or x over 2. They mean the same exact thing. The first thing I'm going to do is try to isolate x. Get x by itself. This 5 is added, so I'm going to subtract 5 from both sides for balance. X divided by 2 equals 13 minus 5, or 8. I am then going to multiply both sides of the equation by 2. The reason why that is the case is because both sides are divided by 2. The opposite operation would be to multiply. These 2's will cancel because this one's in the numerator, this one's in the denominator, leaving just x. And 8 times 2 is 16. Let's try another one of those with a fraction, because I know that can be confusing at times. X over 3 minus 4 is equal to 10. This is asking what number, when I divide it by 3 and then subtract 4 from it, equals 10. That's all they're asking whenever you deal with these type of questions. First of all, the first thing I'm going to do is isolate x. I'm going to add 4 to both sides. X divided by 3, these zero out. 10 plus 4 is 14. There is a number, when I divide it by 3, it equals 14. To find that number, I multiply both sides by 3 over 1, or just 3. These two cancel out. And 14 times 3 is 42. Now the previous question I multiplied both sides by 2, and this one I multiplied both sides by 3. Why would I have done that? Well, the answer is because the denominator here is 2, therefore I multiplied by 2. And this one, the denominator is 3, therefore I multiplied by 3. So when you've isolated it down to just a fraction equaling a number over here, that's when you can multiply both sides by that number. Now we're going to look at a concept called like terms. Like terms first of all, are when you have numbers and variables. A term is separated by addition or subtraction. So if I have 5x, that is one term. There is no addition and subtraction there. If I have 5x plus 4, that is two terms. If I have 3x plus 4y minus 2, that is three different terms. A rule of thumb is this. You have as many terms as there are addition and subtraction plus 1. There are 2 addition and subtraction here and 3 terms. If there are 5 addition and subtraction, there have to be 6 terms there. Just kind of remember that. Like terms look like this. (3x) and 5x are like terms. 4y and negative 7y are like terms. Even though the 7 is negative and the 4 is positive, what matters is they have the same exact variable. 1/2 t and 3t. Like terms because of the fact that even though this is a fraction, this is a whole number or an integer, they have the same variable. They are like terms. (6x squared) and negative 1/2 x squared. Both of them are like terms because of the fact that they both have x squared. Now let's look at some unlike terms. 3x and 2y are unlike terms because the variable for this one is x, the variable for that one is y. Negative 5b and 7a, unlike terms, b and a. 12x and 3x squared, unlike terms. Even though we have an x and an x, this one is only x to the 1 power, this is x squared, unlike terms. The reason why this is important is because when you're adding and subtracting terms, you have to have like terms, called combining like terms. You can add and subtract all these. You cannot add and subtract any of these. So we're going to combine like terms. (5x plus x). Remember, there's always an understood 1 there. X tells me I'm allowed to add them. There are 5 of them here, 1 of them here, for a total of 6. A very common mistake, very, very common, is to say 6x squared. Because you say here's 1x and here's 2 x's, I must be x squared there. Wrong. The x is what allows you to be able to add them, and then you say, okay, now there's 5 of them here and 1 of them here, therefore there are 6. It's like saying tables. If I have 4 tables over here and 3 tables over there, I add them. 4 plus 3 is 7. But if I have 4 tables over here and 2 chairs over there, what do I have? 4 tables and 2 chairs. I cannot combine them. Likewise, the x tells you, all right, these are the same thing, so therefore I can add them together. 12y minus 10y. The y tells me that I'm allowed to take the difference or subtract. 12 minus 10 is 2. 2y. 8x squared plus 9x squared. The x squared tells me that I'm allowed to add them. What is 8 plus 9? 17, combining like terms. Now we're going to do a couple problems with using combining like terms and multiple step equations. First we have 5x plus 7x equals 36. We combine our like terms. X allows me to add them. 5 plus 7 is 12, equaling 36. There are no like terms over here to add. Now I have 12 times x. I try to isolate x using opposite operations. For balance, I do it on both sides. And 36 divided by 12 is 3. 4x plus 9x equals 52. Combine like terms, x allows me to add them. 4 plus 9, there are 13 of them, equaling 52. Opposite operations tells me to divide by 13. Those cancel out. And 52 divided by 13, 4. Negative 10x plus 22x equals 108. X tells me I'm allowed to add them. Negative 10 plus 22. Unlike signs, we subtract. 22 minus 10 is 12. And take the sign of the larger. Which number is bigger, 10 or 22? 22 is. Therefore, negative 10 plus 22 is positive 12x. Drop down the 108. Opposite operations tells me to divide both sides. 108 divided by 12 is 9. Those are some simple two-step operations with algebra, with combining like terms, and other such problems like that.